In this video, we're going to look at how to simplify radicals, and specifically those with a higher index than 2. Back in Algebra 1, you did a lot of simplifying square roots, such as the square root of 98, and let's think about the process for doing this. So there's a lot of different ways you can learn this. You were taught to do a factor tree, and I can see that this breaks into 2 times 7 times 7. And then you used to pair things up. You'd split this into 2 radicals. You'd put your pairs in the first one. So we have a 7 to the second power, and you got this leftover 2 that would go here. And you would do that because the square root of 7, square root of 7, root 2. And then I used to encourage you to type in your calculator to make sure your decimals match. Square root of 98, and then right underneath of it, if you do 7 times the square root of 2, you should get 9.89 for both of these. So you know that they're equivalent. So let's kind of apply this now to something with a higher index. So again, the first thing you would do is make a factor tree. So let's break down 32 into our primes. It's going to be 2 and 16, 4 and 4, and each of these breaks into 2's. Okay, so what are we going to do with this? So what we're going to do is we're going to make groups this time based on the index. So our index is 3. So if I split this into two cube roots, I'm going to try to put my perfect cubes in one group. So here I have a group of 3. So 2 to the third. And then what do I have left over? I have 2 to the second over here. And I do that because this part simplifies. The cube root of 2 to the third, well, they undo each other and it leaves me with just the base. So the 2 comes out, and I still have the cube root of 4 remaining. So I said the third thing is put it together, leaving your ungrouped items under the radical. So you should see that the ungrouped stuff was the 4. This was our one group of 2 that came outside. All right, let's start practicing now. 4th root of 96, so make your factor tree. This is going to be, let's do 6 times 16, and then 2 and 3, 8 and 2, 4 and 2, and 2 and 2. Remember, you might do your tree differently, but the primes we get will match. Quick way to would check it, would be multiply your primes back together and make sure it equals 96. Okay, so I'm going to split this into my groups and the stuff left over. So I'm looking for a group of 4 of anything. So it looks like I have 1, 2, 3, 4 2's. That's 2 to the 4th here. And then I have some leftover stuff. I have a 2 and a 3 that's going to stay over here. So the 4th root of 2 to the 4th, I get just 2. The other part, I'm going to recopy. The 4th root of 6, put it back together, multiply it. So 2 times 4th root of 6. Again, check it on your calculator and make sure your decimals match to know you're right. Start mixing in some variables now. Let's do the cube root of 16, x to the 4th, y to the 3rd. Again, I'm making my factor tree for the coefficient. All right, 2 groups, the cube root and cube root. So I'm looking for groups here. Looks like I have a group of 2's. So 2 to the 3rd, I have a leftover 2 that goes over here. Now I've got to consider my variables. So x to the 4th. Well, if you've got to expand it to see what that looks like, I have one group of 3 x's, so x to the 3rd, and I have a leftover x over here. And y to the 3rd, well, that is a group of 3 y's. So what happens is I can take the cube root of this first radical. So this is 2x, y, what's left over, times the cube root of 2x. Hopefully that's not so bad for you. Let's try another one. 4th root of 9, x to the 8th, y to the 13th. I'm going to make my tree. I just get 3 times 3, so I'm going to split this into 2 groups. And don't drop your index of 4. So I do not have a group of 4 threes, so I'm just going to put that back over here. And I'm just going to multiply it back together right away. 3 squared would be 9 again. Now x to the 8th. Well, I'm going to have x to the 4th, one group, and I'm going to have another group of x to the 4th. Because remember, keep your base, add your exponents. That's going to be x to the 8th. If you have to, write out 8 x's. Hopefully you don't need to do that because that's kind of tedious. But do it once and hopefully you never have to do it again. You recognize you have 2 groups. Okay, and then y to the 13th. Well, here's y to the 4th. There's 4 of them. Another 4 would be to the 8th. Another 4 would be to the 12th. So I would have 1 left over, y to the 1st over here. Again, just double check your exponents. So 4, 4, 4, and 1. Keep your base, add. Your exponents would add to y to the 13th. So this first radical simplifies to x times y times y times y times the 4th root of 9y, or x squared y cubed times the 4th root of 9y. Try this one on your own. Pause the video, work it out, and then check and see if your answer matches. Okay, you should have done a factor tree for 54, which would be 27 and 2, 9 and 3, and 3 and 3. So you're going to group this. All right, so we've got, let's see, a pair of, not a pair rather, but a group of 3s. So 3 to the 3rd, and then I have a 2 left over. X to the 9th, well, it's going to be x to the 3rd. Another x to the 3rd makes it x to the 6th, and another x to the 3rd would make it x to the 9th. Keep your base, add your exponents. Y to the 5th, well, I'm going to have one group of 3. So y to the 3rd, and I'd have 2 left over, y to the 2nd. 1 z, well, I don't have a group of any z's there I can pull out. So my final answer here is going to be 3. X to the 3rd, because each of these would come out as 1x, y, times the cube root of 2y squared z. Okay, if you're not understanding, I highly encourage you to go back and try the practice videos again. Sometimes I say things quickly and you need to hear it twice.